Okay, so we're going to graph the piecewise function. The first one is x squared, and we know that's an open parabola that starts at 0, 0. Now, the domain that they gave you does include the 0, so we're going to have a solid circle at 0, 0. And then remember, we go up 1 to the right 1 from the turning point. Go back to the turning point, go up 1, 2, 3, 4, to the right 2. So, and then we will go up 9 to the right 3, which we can't do because we're off the graph, but that's what the top part of the piecewise function looks like. Now, the next one is a negative pointing parabola with a vertical shift up 4. So I'm going to go up to 4, but since we don't include the 0 in that domain, we're going to have an open circle, and then we're going to go down 1 to the right 1. Then we're going to go back to that turning point at 0, 4 and go down 1, 2, 3, 4 to the right 2. Then go back to the turning point again and go down 9 to the right 3. And there is your second graph. All right, so number 2, we are going to write an equation. So we have f of x equals, we don't know what the leading coefficient is, so we're going to call that c, and that is supposed to be an x. And we have one of our zeros is at x equals -3, but notice we have a tangent, so that means that that factor is going to be squared. Okay, that should be a plus sign. Okay, our next 0 will be at x equals -1, which means its factor would be x plus 1. And then our next 0 is at x equals 4, so that would be x minus 4. And let's just talk about that. Remember, when we have a ricochet off of the x-axis, a bounce off the x-axis, the exponent is squared. When we have a change in concavity here, the exponent is going to be cubed. All right, so now we need to find the c value, so we're going to use that turning point, or I should say, I'm sorry, we're going to use the y-intercept, which is 0, -120. And we're going to plug that in for x and y respectively so that we can find the c value. So -120 equals c. Now we're plugging in 0 for x, which is going to be 0 plus 3, which will be 3 squared, and then 0 plus 1, which would be 1, and then 0 minus 4, which would be -4, and that quantity cubed. So -120 equals c times 9 times 1 times -64. When you multiply that right side out, you're going to end up with -576 times c. And we're going to divide out that -576, and we will get c equaling 5 over 24. So the final answer will be f of x equals 5 over 24 times x plus 3, that quantity squared, times x plus 1, times x minus 4, that quantity cubed. All right, so number 3, we are going to be writing a piecewise function. So we've got 3 parts there, so we should have 3 equations. I'm going to tackle the one on the left, which is this parabola, which is x squared. But notice that the domain is at 1, it includes it, and anything less than 1. So that means we would have the equation x squared when x is less than or equal to 1. Then we look at the second part right here, which is a horizontal line. Its equation is y equals 3, but we don't include 1, but we do include 2. So the equation is y equals 3, and our domain will be not including 1, but including 2. All right, and lastly, then we're going to look at the last line right here. And if you keep following this and we go down 1 over 1, because that's the slope that we have here. Look, up 1 over 1, up 1 over 1. Or we can go left, down, left, down, left, down, left, down. You can see it's the line y equals x. So we've got the line y equals x. And the domain would be when x is greater than 2. We don't include 2 because there is an open circle. All right, so if you read through number 4, we're going to start by finding the slope. So we are going to do 2 minus 6 over 4 minus negative 2, which will be negative 4 over 6, which reduces to negative 2/3. Now it does say slope-intercept form, which is y equals mx plus b. So we do have a line perpendicular. So if this is the slope of the regular line, then the slope of the perpendicular line will be the negative reciprocal. So that's what I'm putting in here, 3/2 x plus b. It tells you that it passes through the point negative 2, 8. So I'm going to put in 8 for y. And I'm going to put in negative 2 for x, which is going to cancel those guys out, but not the negative. So 8 equals negative 3 plus b. If you add that 3 over, you're going to get 11. So your final answer is y equals 3/2 x plus 11. We're going to solve for cosine. So I'm going to bring this radical 3 over by subtracting it. And I'm going to get 2 times the cosine of, equals, 2 cosine theta equals, negative radical 3, and then divide out that 2. All right, so this is asking what angle has a cosine that's negative radical 3 over 2. Well, I know radical 3 over 2, the angle whose cosine is radical 3 over 2 would be 30 degrees. However, because I have this negative right here, that tells me that my cosine is in the second quadrant and the third quadrant, because all students take calculus. All students take calculus, and cosine is negative in that second and third quadrant. So I'm looking for a second quadrant answer, and I'm looking for a third quadrant answer. Well, 30 degrees in the second quadrant is 150, because you do 180 minus 30. And then in the third quadrant, it would be 180 plus 30, which would be 210. Now, the directions tell you that you have to put things in radians. So I know that 30 is pi over 6. So I know 150 and 210 are multiples of that. So I know I'm going to have some kind of a pi over 6. And the same thing here, some kind of a pi over 6. And then I just ask myself, what do I multiply 30 by to get to 150? And I multiply by 5. So that's the number that's going to go right in here. And then you do the same thing for the 210. 30 times 7 would give me 210. So those are your two answers. Okay, now for number 6, we have cosecant. And I know cosecant goes with sine and that they're reciprocal trig functions. So sine would be 1/2. And then I know that that would be a 30-degree angle. And I have a positive 1/2, so I know that I'm in the first and the second quadrants because that's where sine is positive. And 30 degrees would be the first quadrant angle, and that's pi over 6. And then in the second quadrant, I have 150, which would be 5 pi over 6. All right, number 7. Well, we've got a quadratic now. So when I have a quadratic, I like to get everything on one side of the equal sign and set it equal to 0. And then I'm going to factor this. So I'm going to have sine x and sine x. And remember, I'm trying to figure out what multiplies to -2 and adds to -1. So that would be -2, and that would be +1. Okay, we do a little t-chart here. We have sine x equals 2. Now remember, that's going to reject because we can't have a sine or a cosine value that's larger than 1 or less than -1. So that is gone. Over here, I have sine x equals -1. So the angle whose sine is -1 is 3 pi over 2. Make sure you know all of your unit circle and your special angles chart information. Okay, so then the last one here, everything in number 8 is set equal to 0. The problem is that I have a lead coefficient that's not a 1. So remember, that's where you rainbow. So we're figuring out what multiplies to a +2 and adds to a -3. So then I am going to, you know what, I'm going to scoot this one down here, if that's okay. So we drop the first term down, so that's 2 cosine squared x. And then I'm going to have -2 cosine x minus 1 cosine x, because those two add to -3 and they multiply to a +2. Then you drop down the last term. Okay, we're going to group and group. So we're going to have 2 cosine that I can take out of that first group and get cosine x minus 1. And over here, I'm going to take out a -1, and I'm also going to get cosine x minus 1. So I have 2 cosine x minus 1 and cosine x minus 1 equals 0. T-chart. So on the left here, I have cosine of x equals 1/2. So that means my angle is going to be 60 degrees. And it's positive, so I want the first quadrant answer, which will be 60, which is pi over 3. And then I want the fourth quadrant answer because cosine is positive in the fourth quadrant. So 60 in the fourth quadrant will be 300, which would be 5 pi over 3. So there are your answers on the left-hand side. Now let's go over here on the right-hand side. We're going to get the cosine of x equals 1. So x would be 0, and it would also be 2 pi. And if you look at the domain in the directions, 2 pi is in that domain, so we can have that as an answer. All right, last one in this section, I would subtract over the radical 2. Please remember, that's a 1 radical 2. So when you subtract that over, you're doing 2 minus 1 right here on the right-hand side. So you're going to have secant of x is equal to 1 radical 2, or just radical 2, which then means that the cosine is the reciprocal of that, which is 1 over radical 2. Now, we can't have a radical in the denominator, so remember we need to rationalize that. So we're going to multiply both the numerator and the denominator by radical 2, and that's going to give us radical 2 over 2. Okay, now the angle would be 45 degrees, right? So we want to know what quadrant we're in. So let me just go back here. We know that we have a positive here. So then the quadrant we would be in would be where cosine's positive, which is in the first and the fourth quadrant. So in the fourth quadrant, remember it's 360 minus, which would give us 315. In radian form, that's pi over 4, and this is 7 pi over 4. 10, I am going to take that out of radian form, and that's the cosine of negative 150 degrees. Well, let's figure out where negative 150 degrees is. Do you see that that is in the third quadrant? Which means my answer is going to be negative, because if I do all students take calculus, you can see that the cosine is negative in that quadrant. Then I know that 150, its reference angle is 30 degrees. So basically, I want to know what's the cosine of 30, which I know is radical 3 over 2, but again, cosine is negative in that third quadrant. All right, 11. So 7 pi over 6 is going to be 210 degrees, which puts me in the third quadrant, right? I'm going to start by backing up a second, and I know secant goes with cosine, so let me find the cosine of 210, and then all I have to do is flip that. Well, the cosine of 210 is the same as the cosine of 30, because 210 degrees is in the third quadrant, right? In the third quadrant, and I know the reference angle in this quadrant is the angle that's given, which is 210 minus 180, and that's how I got the 30. But remember, we're in the third quadrant, so my answer is going to end up being a negative number. So that's going to be negative radical 3 over 2. Now that's for the cosine of 210, but I want the secant. So the secant has to be the reciprocal of that, which would be negative 2 over radical 3. Now, just like in one of the other ones that we did, you're going to have to multiply by that radical 3, because we can't have a radical in the denominator. So my final answer is going to be negative 2 radical 3 over 3. All right, so I like to, off to the side or underneath, I'm going to write down that what the amplitude is. So the amplitude is 1. The vertical shift is going to be 2, and we're going to be going up. My horizontal shift, or my phase shift, is going to be pi over 4. I'm going to be going to the right. And let's see, what else do we need? We need the period of the graph, right? Well, the period of the graph is 2 pi times the frequency, and if you look right here, the frequency is a 1, so the period is 2 pi. And lastly, the interval is going to be that 2 pi divided by 4, so I know my interval is pi over 2. So basically, I'm going to put 4 slashy things, and each of those is going to be an interval of pi over 2, going up in pi over 2 increments. All right, so my amplitude is 1, but I do see I have a vertical shift of 2, so I'm going to go 1, 2, 3, 1, 2, 3. Now remember, I like to draw the picture before any shifting, so I'm really just going to draw y equals cosine x. So I know cosine starts and finishes up, and in the middle it goes down to negative 1. And then in between the max and the min, we hit the x-axis. So max, oh min, oh max for all you Missed and EC people. So there you go. Okay, so now we have to shift this. So we are going to move each point. We are going to move that point to the right, pi over 4, and then we are going to then shift up 2 units. Okay, well, if I look at this, my x-axis isn't in increments of pi over 4, but I know pi over 4 is, oops, thought I had my pen going here. I know that pi over 4 is in the middle right there. So I'm just going to put some little slashes right smack dab in the middle. So each of those red slashes represents the middle of my original intervals of pi over 2. So this is what I mean. So I'm going to take this point and I'm going to shift it to the right pi over 4. If I went all the way over here, guys, that's a shift of pi over 2. I don't want that. So I'm just going to go right over to here. And then I have to go up 2. 1, 2. And right here is where I'm going to put my first dot. All right, so let's go to the next one. So I'm going to take this point, I'm shifting it to the right pi over 4, so to the next red dot, and then I'm going to go up 1, 2, and that's where I'm going to put my next point. And then I'm going to go to the next point, which is right here. I'm going to shift to the right pi over 4, and then I'm going up 1, 2, so right there. I'm going to do the next one. So I'm going to 3 pi over 2. I'm going to the right pi over 4. Then I'm going up 1, 2. So it should be even with this guy right here. Okay, right there. And lastly, this one I'm just going to have to draw another little slashy thing here. I'm going to move this one to the right pi over 4 and then go up 2. So it should match the height of this guy. So up at 3. And there is your new curve with that as the equation. All right, so then for number 13, you can take a look at the amplitude and so on down there. So similar to the last one, I'm going to go in intervals of pi over 2. So pi over 2, pi, 3 pi over 2, and 2 pi. I have an amplitude of 3, but then I have a shift of 2. So I'm going to 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. Okay, so my original graph is just going to be 3 sine x. So let me just graph that one first. Well, remember, a sine curve starts, finishes, and in the middle goes to 0. Then at pi over 2, it's going to go up to its maximum, which will be 3. And then at 3 pi over 2, it'll go down to its minimum, which is negative 3. Now we're going to be taking this, and we're going to be shifting it pi to the left, and then down 2. Okay, now I need to shift this graph pi to the left. So if I look at this point, I don't have anything over here. So I am going to just put some slashes in. There's negative pi over 2, and here's negative pi. All right, so I'm going to take this point, and I'm going to shift it to the left, pi, and then I'm going to go down 2 and put a dot. And then I'm going to go to the next point, and I'm going to go to the left pi. Well, this is only pi over 2, so I got to go another pi over 2, and then I'm going to shift down 2, so it would be right there. I'm going to do the same thing. So there's the first part of my graph. Okay. Then I'm going to go to the next one here, and I'm going to shift to the left pi. That's only pi over 2, so I have to go another one, and then go down 2. Okay, so that's going to be, let's see, down 2 right here. Then I'm going to do the same for the next point, and that's going to put me right there. And there's my graph. Y equals 3 sine x plus pi minus 2. All right, so for number 14, just check out everything I have over on the right, and that would be the graph of your original y equals negative cosine x. Now what we're going to do is we're going to take that graph and we're going to shift everything to the left, pi over 4, which is going to require me to put slashes in between. So I'm going to scoot to the left pi over 4, and then I'm going down 1. So left pi over 4, and then I'm going down 1. Okay, next point, all the way up here, I'm going to be going to the left pi over 4, and then down 1. So right there on the x-axis there. Okay, then the next one, I'm going to go to the left pi over 4 and down 1, so down here. Okay, and then the very last one, I'm going to go to the left pi over 4 to this little red slash right here, and then down 1, so I'll be down here. And there's your graph of y equals negative cosine x plus pi over 4 minus 1. Okay, so there's the graph of 3 cosine x. And we're going to take each point and we're going to shift it, we're going to shift it to the left pi over 2 and then down 2. So this point here, I'm going to go to the left pi over 2. Let's just label this. So this is going to be negative pi over 2. Okay, so I'm going to shift this to the left pi over 2, which is going to be right here. And then I'm going down 2. And then you're going to repeat this for every point. And that would be what your graph would look like in red. Okay, so let's go on to 16, and let's find the amplitude and so on for that one as well. Okay, now this graph is a little bit different because there are no shifts. So I kind of went back to our old method here. We know the amplitude is 3. The frequency is 4. Now remember, this frequency means how many curves you're going to see from 0 to 2 pi. So we're going to see 4 curves from 0 all the way to 2 pi. And this period is telling me it's going to take this long to get one full curve in here. So I'm going to have one sine curve by the time I get to pi over 2. Okay? And I am going to have a flipped sine curve. So everything's going to be, instead of going up first, the graph will go down first. So that's what your first sine curve will look like. We have one sine curve flipped upside down because of the negative, and one sine curve is done by the time we get to pi over 2. Now we repeat this 4 more times, or 3 more times really, for a total of 4. There's the second one, there's the third one, and there's the fourth one. And don't forget to write the equation on your graph. Okay, so 17, we have to evaluate 17 and 18. Well, I know that with a 6 in the denominator, that's some multiple of 30. And so I'm going to do 30 times that 5. So that's going to give me the sine of 150. This is a multiple of 60 times the 2, which would give me a cosine of 120. All right, so let me go a step further. 150 is in the second quadrant, so I know sine is positive, and its reference angle is going to be 30 degrees. And I know that cosine, this is also in the second quadrant, which will be a negative, because cosine is a negative in the second quadrant, and the reference angle is 60. Okay, so the sine of 30 is 1/2, and I'm going to change this to a minus because I've got plus and negative, and the cosine of 60 is 1/2. So your final answer is 0. All right, we're going to do the same thing with 18. So just be careful here. Tangent of negative 7 pi over 4. Well, negative 7 pi over 4, I know is 300. 315 degrees because it's a multiple of 45. But negative 315 actually goes around this way, right? So really, its reference angle is just 45 degrees. So this is the tangent of 45 degrees, and since I'm in the first quadrant, I know my answer is going to be positive. Plus, and then this is the tangent of, well, 3 pi over 4 I know is 135 degrees. Okay, and tangent of 135 degrees is going to be a negative number because 135 is in the second quadrant, and tangent's negative in the second quadrant. Well, the tangent of 45 is 1. I just said tangent of 135 will be a negative, and its reference angle, though, is still 45 degrees, so that would also be 1. And subtract, you'll get 0. Okay, so we're writing the equation. Well, I know this is a sine curve, and I know that the amplitude is 5, so I know that's going to be 5 times the sine. Okay, so let's just look right here. That curve ends, and that's at pi. So the number that should go right here in front of the x would be how many curves you see from 0 to 2 pi. So we actually will see 2 curves. So my equation is y equals 5 sine 2x. Okay, if we look at number 20, you should notice that things aren't even like they were here. See, like I have a distance of 5 from the x-axis up and from the x-axis down, but I don't here. I have 2 up here, but I've got 4 down here. So this total distance from my maximum here all the way down to my minimum here is a total of 6. So if you take that middle, okay, and you count, you're going to get, sorry, I can't add, it's a total distance of 8. Okay, so you get a total distance of 8 because you've got 2 here and then 6 more here, total of 8. So I'm going to cut that in half. So I can count from here. I'm just going to count up 4. 1, 2, 3, 4. So right here is where the x-axis kind of should be if we were thinking in a perfect situation here. Okay, so let me just draw that so you can see that better. Can you see now that when I draw that line, which is y equals negative 2, okay, let me get my pointer going here. You can see that the distance from here to the top or from here to the bottom is a distance of 4. Okay, so that makes this part of the graph and this part of the graph even, just like we had over here and over here. So the amplitude of this graph is going to be 4. 1, 2, 3, 4. Or you could look at it this way. 1, 2, 3, 4. So when I'm writing the equation, then I'm going to write y equals 4. I know it's a sine curve. How many curves do you see from 0 to 2 pi? And I see 1. But if you notice, what happened was this whole graph, let me just get my red going again. This whole graph shifted down a distance of 2. So then we should have minus 2. All right, let's look at 21. And we kind of have a similar situation here, where my peak or my maximum here is at 8, but my minimum is at negative 6. So we went all the way up to 8, and from there we went all the way down to negative 6. So that total distance from this maximum, to this minimum is a total of 14, right? So I want to kind of count backwards, and I want to count and figure out, I know that half of 14 would be 7, right? So I want to count from negative 6, and I want to count up 7. So 6, 7. So right here would be where I would have that horizontal line like I drew in number 20. So right here at y equals 1, right there, we call that the midline. Okay, so that midline is where the distance from this line up to the top or from this line down to the bottom would be the same.
Okay, and this would be a distance of 7, so the amplitude of our graph is going to be 7. So we've got y equals 7. It is a sine curve. Now, how many curves do we have from 0 to 2 pi? Okay, and well, this right here is 1 pi, so that means this is 2 pi. So we're only looking at a half of a curve from 0 to 2 pi. So that's going to be 1/2. Okay, and then notice everything here shifted up 1, up 1, up 1, up 1, up 1. Your midline is really your vertical shift, so we're going to write +1.